Welcome to Theory of Computation. Here I am going to discuss a few topics in Unit 5. So Unit 5 contains undecidability. In an undecidability, there are different types of languages are available. So I am going to discuss the different types of languages which is used for undecidable problem and how to rectify or how to find a solution for unsolvable problems, and a few notations which are relevant to undecidability. So these are all the topics which is available under Unit 5. So if you consider a Turing machine, one type of Turing machine is called as offline Turing machine, which means that offline Turing machine is implemented by using a multi-tape Turing machine, and that Turing machine should contains a read-only format of input tape. So if any multi-tape Turing machine with the read-only format of input tape is available, then that is called as offline Turing machine. So if you consider problems, there are three types of problems are available: solvable problems, unsolvable problems, or partially solvable problems. So if any problem is solvable, or if you find a solution for that particular problem, so it is considered as decidable problem, and the corresponding language is called as recursive language. It is denoted as LR. If a problem cannot be solved by any particular method, then that type of language is called as not recursively enumerable, which is shortly noted as LNRE. If we find a solution under a certain conditions, then those type of problems are called as solvable problems, and that type of language is denoted as recursively enumerable language, that is LRE. So there is always a relationship between LR, LRE and LNRE. So this is the type of language. So all problems are initially treated as not recursively enumerable problem. So it is denoted as LNRE. Then if we find a solution with a certain condition, then that problem is called as recursively enumerable problems. Then if we find a solution for all situation, then that is called as solvable problem, and the language is called as recursive language. So it is denoted as LR. So these are all different type of languages. So U means universal language, D means diagonal language, E means empty language, and NE means non-empty language. Here LD bar, it is a complement of diagonal language, and LU bar, it is a complement of universal language. So these are all different type of languages which are all relevant to both decidable and partially decidable or unsolvable problems. So if you consider a complement of universal language and a diagonal language, then empty language. So these three are comes under LNRE, that means undecidable problems category, and universal language LU, complement of diagonal language LD bar, and non-empty language LNE. So these three languages are comes under a partially solvable problems, that means it comes under LRE. Then if we consider a recursive language, it is denoted as LR. So in which situation a language is called as recursive means if W is a string and that string is accepted by a Turing machine M with a particular condition, means it will accept it. So the Turing machine will accept the language and it will produce S as an output. Suppose the string W does not accepted by a Turing machine, means that machine will give an output as no. That means it will, that string is rejected by the Turing machine. So the output of the Turing machine is yes no format, depending upon the string is accepted or not accepted. So this clear-cut format of language is called as recursive language, that means LR. Decidable or undecidable problem means a problem whose language is recursive. That is called as decidable problem. If it is not recursive, then that problems are considered as undecidable problem. So if we consider an undecidable problem, there is no specific algorithm for a certain type of inputs. We can only make an assumption for a particular situation. For example, a set of string of equal number of zeros and ones. That means that either it starts with 0 or end with 1, starts with 1 or end with 0, or combinations. So we cannot able to predict it. So these are all comes under undecidable problem. Recursively enumerable, LRE, means if that string W is accepted by a Turing machine M, it will accept that string with S type. If W is not accepted by a language, then the machine will go to an infinite loop. So this type of output comes under LRE. So recursive enumerable language. In this category only, universal language, complement of diagonal language, and a non-empty languages are occurred. So if we want to prove an undecidability, we should take the input in a binary format, that is called as encoding. So if you consider a string, that input of that value should be in the format of zeros and ones. So the machine should accept that string only in 0 and 1 format. For implementing that category, we should go for encoding of Turing machine. This concept will be discussed in next class. Thank you.